Hi everyone, we're Team 12808 and this is our Afterglow presentation. So today we'll be talking a bit about our experiences in FTC. To introduce myself, I am Mark. I'm a high school senior, mechanical subteam lead, and this is my fourth year in FTC. Presenting with me is Michael, who's also a high school senior, mechanical subteam lead, and is fourth year in FTC, and Sai, um, who is currently a sophomore in high school and captain of the team, and also fourth year in FTC. So let's get into what we're going to be talking about. Firstly, Michael will present on the failures that we have gone through. Next, I'll be presenting on some general lessons we've learned as a team. And finally, Sai will cap it off by highlighting some of the personal growth and learning that FTC provides. We're based in Portland, Oregon, and if you're wondering how we got our name, I have a little fun fact. So after our predecessor, Hotwired, which is Team 7013, was disbanded, we decided to make our team name include something about electricity in order to pay homage to them, hence the amp in our team name, the unit for current. So below you can see the seasons we've participated in and are participating in, and also where we got in those seasons.
So the first thing we're going to be talking about is failure. We've had a lot of failures, but perhaps the most educational ones are the three mechanisms I'm going to be talking about to you today. And we learned a lot from building and designing them, and we hope with this presentation you will too. So the first thing is the dumper, and this was a tray that we used to unload foam blocks called glyphs in the FTC Relic Recovery season. And basically, we decided that at the last minute, maybe like a week or two before Worlds, we wanted to change this dumper. So I don't know if you can see, but on the bottom right of your screen, you can see the tray, or like the dumper. It has two flaps on the side. And basically our idea was to kind of make those flaps clamp so that it would be able to hold the blocks in more securely. We thought this would be a pretty significant improvement, and so we went ahead and just executed on it. However, what ended up happening was we pretty much got a minimal performance payoff. We really didn't see much improvement at all. It cost precious time, obviously, which was time we really couldn't afford to be wasting, and that resulted in less driver practice, which meant we had less familiarity with the robot. And when you're on the world stage, I mean, that's pretty much where your palms are sweaty, knees weak, arms are heavy, right? So you can really use all the familiarity with your robot that you can get. Also, by adding a servo-driven clamp on the back of that dumper, we added unnecessary complexity and an extra point of failure on a robot. So the main takeaway we got from this was to, before a major competition, you should fix stuff, but don't overhaul anything, which is kind of ironic considering our whole team name is Revamped Robotics. Anyways, also make sure to really consider the potential consequences of your changes before you make them, and even if you do, or once you do, I guess, you should make sure to have a backup plan so that you can revert changes quickly, or just find a way to mitigate any negative consequences should they appear. The next mechanism I'd like to talk about is the popper. This was used in the Robo Ruckus season and failed really spectacularly in Worlds at the division semifinals. We couldn't really do anything about this because we were between matches at that point, and it pretty much just ended our career, I guess you could say. And the main reason for this was because it was a spring-loaded component, which meant that the motion profile of the popper arm was very violent, and after thousands of repetitions, the aluminum bar just gave out and failed due to fatigue. There were a couple really valuable things we learned off of this, and so I thought I'd show them here today. The first is the idea of a consumable or wear component, right? This popper arm was a component that was subjected to repeated stress and a really intensive use case in general, and that's what a wear component really is, right? It's one that is because of its use case, prone to wearing out quickly and needing to be replaced. So it's really important that you identify these components on your robot so that you can pay extra attention to their condition and replace them before something goes horribly wrong. The failure of our popper arm also showed us the benefits of proactive maintenance as compared to reactive maintenance. Um, so if you'll notice, you know, like this mechanism just like really failed spectacularly, and we could not sort of muster a viable solution after it became apparent like that it was a problem. Right, by the time the bar had cracked, it was already too late, and gaff tape wasn't going to save this thing. So this is where proactive maintenance really shines, because it allows you to preemptively replace like components that are beginning to fail or have already failed, but haven't really sort of manifested themselves in the functionality of your robot yet. And that basically allows you to mitigate any negative consequences in terms of like scoring, right? So you'll never lose a single point due to a maintenance issue if you properly maintain your robot, like proactively. The failure of our popper arm also showed us the importance of a functional versus a visual inspection, and sort of the importance of both, right? Before the incident, we had mostly been doing functional inspections. So we would turn the robot on, click all the buttons and stuff on the controller, and if it seemed to work and everything sounded all right, we would give it the green light. However, with this, very visually obvious failure, we realized that a visual inspection is also very important, and even having a brief look at your robot can really show you a lot of stuff that's wrong with it. The third concept that we kind of picked up was the idea of a keystone component, and this is kind of unofficial terminology, but I think it's still pretty important. And a keystone component is basically one that your robot relies on for scoring, and it really becomes important when your keystone component is also a consumable component. So as in the case of our popper arm, because when it is, that kind of means that one of the components that you rely on, that you critically rely on for scoring, is also very prone to failure, and that means that you're really going to need to pay extra attention to this keystone consumable component. The last mechanism I'd like to touch on is the swerve drive. So this was, this is one of the more complex drivetrains you can build in FTC, and it turned out to be a very time-consuming project for us, both in terms of designing and building it. And the complexity of this drivetrain resulted in numerous hardware and software issues. So, for example, right, we killed over 10 servos just on this drivetrain alone, which is not only financially costly, but also meant that we had to spend a lot of extra time replacing them, and it kind of gave us trust issues with our drivetrain, right, because of the reduced reliability. There were two main things we learned from this experience. So first of all, there is no need to be a hero in terms of design, right? Making the most unique design does not necessarily mean that you have the best design. Sometimes, if you are really after performance, it could just be better to do what everyone else is doing and optimize it a little bit for your use case. The second thing we learned is that it's better to underestimate your capabilities than overestimate them. If we had just built, for example, a much simpler drivetrain like a Mechanum, we would have gotten a lot of extra time, and we could have used that for design optimization and driver practice. We've noticed that a well-built, really simple design is much better than a complex design that was poorly executed on, such as our swerve drive. So, in the next part of our presentation, we'll be going over some general lessons we've learned that don't necessarily branch from a single failure, but are just kind of based on our experience.
Hi everyone. I'm going to share some lessons we picked up over our years at FTC that might be helpful to you. In the middle of our first season, we found ourselves in a bit of a sticky situation. We had winter break, and we wanted to pivot our design completely. So we wanted to basically redesign our robot in winter break. We knew we didn't have enough time to prototype, and to experiment. So we turned to the internet and checked what other teams were doing. And this has been one of the most useful lessons we've learned over the years. Like, no matter how good you think you're doing, there's always some other team that is doing something better than you. Um, so be aware of what other teams are doing. Know what works and what doesn't, and it'll save you a lot of time down the road. Uh, Use other teams' designs. Like, don't just straight up rip them off, but you can learn a lot from looking at how other people approach problems. And if you make the effort to really understand the design and why particular decisions were made, you'll find that you'll improve a lot at designing and critical thinking. In our second season of FTC, which was Rover Ruckus, we went from a small team of 8 people to 12 people, and what happened was it was more work for everyone. And how is that possible? Well, there were several factors, but one of them was an inefficient system for team organization and scheduling. So we started out with a sort of centralized system, but with a bigger team, it was kind of creating some bureaucracy. So you need to be sure to organize and schedule properly. So the first way to do this is to get communications, and we do this through Slack. We split into different channels for different things. So we have channel for meetings, we have a channel for design, programming, drive team, etc. Um, and what you'll find is this subdividing is very helpful for large teams. So our team is getting larger, and we split it into 4 sub-teams, one that does programming, and the other 3 that are each dedicated to designing and maintaining a robot subsystem. This allows us to be more agile and coordinate more easily. Um, each sub-team meets a few set designated times a week that are decided by the members, so you can avoid schedule conflicts. And it also means that very few people will be in the shop at any one time, which allows everyone to work more efficiently. Another factor that contributed to our stress in the Rover Ruckus season was the lack of dedicated time for brainstorming and planning. We committed quite early to a design that was really hard to change, and ended up with a very over-engineered robot with a lot of complexity and a huge number of things that could go wrong. And, as you previously heard, they did. So the robot was quite unreliable, and a lot of our time was dedicated to robot maintenance, which distracted from the amount of time we could use to actually improve our design. The lesson here that you should bide your time when it comes to planning. Remember that knowing what you're going to build is just as important as having the time to actually build it. There's a famous quote by Abraham Lincoln, and it goes something like, "If you give me 6 hours to chop down a tree, I'll spend the first 5 sharpening my axe." So do that for FTC. You need to plan. Um, Obviously, don't spend 5 out of 6 hours in your season planning, but definitely make sure you dedicate enough time to planning so that you can avoid lots of headaches in the future. There's a minimum of 5 months between the end of Worlds and the start of a new season. During this time, it's easy to forget a lot of valuable information and lose touch with your teammates. So we like to do a number of things over the summer, including outreach, training new members, learning, and sometimes even team bonding. Every summer, a few members from our team research and present about some topic, whether it be types of screws or ways to string a slide. It's a great way to retain knowledge and prepare for the season ahead. I've personally learned CAD over the summer, which has helped me dedicate more of my time during the competition season to design. The purpose of the summer activities is like a warm-up. You want to be ready for the kickoff, but you also need to avoid burning out. So have fun and keep it low-key. So the final and most important skill is to learn how to reflect. This is basically how you improve. We personally, on my team, we have full team meetings dedicated to reflection after every competition and every season. This helps us set clear goals for what we can do better next time. And that's what's really important, improvement. It doesn't really matter where you're at right now. As long as you can keep improving, you'll eventually reach your goal. And so, with that said, I'll hand it over to Sai to talk about his personal growth.
Alright, so now we're going to move on to the more personal aspects of what we've gained through FTC. So let's start why I joined programs in the first place. I started first in FLL in 4th grade, and I participated in it for 3 years. Before joining first, which this year currently will be my 4th year. But that switch wasn't immediate. Instead, I learned about it through many different sources, such as others in my community that have participated in FTC, as well as my older sister, who is part of an FTC Team. And this idea of solving mechanical challenges was actually a big interest to me, as well as FLL just didn't stimulate my brain enough. So why did I join? Two reasons I started off with joining were the two most surface level ideas of FTC, which is the ability to work with metal and just the idea of robots in general, which just kind of intrigued me. So after being part of an FTC team for now 4 years, I'm bound to have learned things, right? So regarding the STEM parts of first, it's definitely a super intuitive way to learn engineering, designing, programming, and just the whole concept of tracking down your progress as you go through a design cycle. I learned that there are many key principles of mechanical design and manufacturing, one just being that you start with CAD. CAD is it stands for Computer Aided Design, and it's a tool that allows you to design and test your parts before actually consuming resources, and it's really nice. And through Engineering Notebook, you can actually tell the story of how your robot works in more elaborate written format, and it's also a good way to reflect not only on your robot in the current year, but in the long term, it's a really good way to reflect on previous years as well if you plan to have be a team for over 1 year. FTC is also a great way to understand how industrial conditions are. By using the machines in the shop, such as bandsaws and drill presses, you can get a lot of insight on how to work in an industrial environment. And since you're working with this heavy machinery, it is also important to make sure you know how to properly use safety gear. And finally, you'll also learn a lot through older team members on how to properly create parts with precision if you are joining a team that's already been around. Okay, so I've now talked about some STEM concepts, right? And what I've learned from them. But what have I learned outside of FTC? Or what concepts have I learned from FTCs that can be applied to outside? So let's start with teamwork. FTC greatly encourages teamwork, and as a result, I've learned to design and work much better with other team members. Something you should know is that FTC is generally a major time commitment, however, and this does not lie purely in the mechanical aspect of it, but it's mainly due to the various amount of workloads that you'll get. A general rule is that the more time that you put into FTC, the more you'll actually get out of it. Through many presentations that I've given in FTC, being presentations within our team or presentations outside of our team, just like this one, I've learned to get much better at speaking in general. And, okay, the final thing that I've learned from FTC that applies outside of STEM is gracious professionalism. This is definitely unarguably the most important takeaway and core value in all FIRST programs. In everyday life, it's really useful because it teaches you how to converse and respect everyone, I guess. And in FIRST, it shows you that it's not all just about the robots. Okay, so now who am I after FIRST programs, right? Well, I'd like to say that I'm much stronger than before when it comes to leading anything, be a few members in the entire team, or just be the entire team itself. Before, I used to actually be really nervous when talking in public or even leading projects, but right now, I'm more confident than I used to be, and I honestly thought I'd never get here. Thanks, FIRST. FIRST has also really helped me become more independent by allowing me to work both alone and learn how to work by myself, rather than just be the one who follows extrinsic factors and other things, right? It has helped me understand how work is distributed and understand the advantages or disadvantages between collaborative work and non-collaborative work. Now, I'm also much more confident in my ability to commit to projects as well. Just kind of because this is because I didn't have as much confidence in my ability to work as much as now. You can kind of see a trend here, right? Can't you? And I also feel much more productive when it comes to products now. So I'm really a lot more confident as a whole of a person after FIRST programs. So overall, how's FTC? Well, FTC is definitely a wonderful experience for sure. There's a lot that I've learned, and with a broad range of topics being in both STEM and non-STEM categories. The STEM categories, or some categories, wow, I cannot speak. There's mechanical engineering, programming, and teamwork. And in our everyday lives, time management, organization, and preparedness are also really useful. And finally, it just really helps you build character and lets you shape you into yourself, your true self. Alright, thank you for listening. If you got any questions, please ask us now in this live Q&A. And by chance, if your question doesn't get answered, you can also always contact us at revampedrobotics@gmail.com. You can see it on the bottom of the slide. And we'll do our best to answer your question as fast as possible. Thank you.